Hello everyone. In this video, we're gonna talk about a topic that is one that sounds almost too good to be true. A money that keeps paying out forever. We're talking about perpetuities. Now, think of an endowment fund that pays scholarships every year indefinitely, or certain government bonds historically issued without a maturity date. That's the real world idea behind a perpetuity. And now, we will break this down into four types: ordinary perpetuity, perpetuity due, ordinary general perpetuity, and general perpetuity due. And I'll give a short example for each. Let us start with the core definition. A perpetuity is a series of equal periodic payments that continues indefinitely, meaning forever, with no end date. Since the payments never stop, we can't compute a future value for perpetuity. It would be infinite. Instead, we only ever compute its present value, how much the endless stream of payments is worth today. The present value turns out to be a finite number, because money further and further in the future is worth less and less today. That's the magic of discounting. First, let us start with the simplest case, the ordinary perpetuity. Here, payments happen at the end of each period, and the payment interval matches the interest conversion period. The formula for present value is P is equals to A over I, where A is the periodic payment and I is the interest rate per period. Let's try an example. Suppose a fund pays 5,000 at the end of every year forever, and the annual interest rate is 5%. We have P 5,000 over 0.05, or 5%. This gives us 100,000. So to generate 5,000 every year forever at 5% interest, you need 100,000 pesos today. Now, let us move on to perpetuity due. This is almost the same idea, except payments happen at the beginning of each period, instead of the end. Since the first payment happens immediately, we get one extra payment today compared to the ordinary case. Now our formula becomes P is equals to A plus A over I, or equivalently, P is equals to A over I times the quantity of 1 plus I. So let's use the same numbers. We have 5,000 per year, 5% interest, but now it is paid at the start of the year. So here we have P is equals to 5,000 plus quantity of 5,000 over 0.05, or 5%. Now this gives us 105,000 pesos. It would make sense since you're getting paid right away instead of waiting a year, and the whole stream is worth a bit more. Now, things would get a little bit more interesting. In a general perpetuity, the payment interval and the interest conversion period don't match. For example, payments might be made annually but interest compounds quarterly. To handle this, we first find an equivalent interest rate that matches the payment period, then apply the same ordinary perpetuity logic. Hence, our formula is P is equals to A over F, where our F is equals to the quantity of 1 plus I raised to C minus 1. Here, I is the interest rate per conversion period, and C is the number of conversion periods per payment interval. Now let us try the example. Suppose the payments of 6,000 are made at the end of every year, forever, but interest is compounded quarterly at a nominal rate of 8%. So our I is gonna be 0.08 divided by 4, since it is per quarter. Thus we have 0.02 or 2% per quarter. Then our C is 4, which are the quarters per year. Now, we're going to find the interval, the equivalent annual rate. So RF is gonna be 1.02, since 1 plus 2% or 0.02 is gonna be 1.02 raised to 4 minus 1. It is equivalent or approximately 0.0824 or about 8.24 percent. Then we're going to have our P is equals to 6,000 over 8.24%. Then we have approximately 72,816. So even though the nominal rate is 8%, compounding quarterly bumps the effective annual rate up slightly, which slightly lowers the present value needed compared to using its flat 8%. Finally, we combine both twist, then we have the general perpetuity due, payments at the beginning of each period with mismatched payment and interest intervals. Now our formula is P is equals to the quantity of A over F times 1 plus F. Now using the same equivalent rate of F from before, now we're going to use our previous example. So still we have 6,000 annually, but now paid at the start of each year with the same quarterly compounded 8% rate, since we already have 0.0824. So we have our P is equals to the quantity of 6,000 over 0.084 times the quantity of 1 plus 0.084. This gives us our P is equals to 78,824. Again, getting paid upfront each period pushes the present value slightly higher than the ordinary version. So let's recap all four types. Ordinary perpetuity are payments at the end of each period, matching intervals. P is equals to A over I. Next, perpetuity due are payments at the start of each period, matching intervals. P is equals to A over I times the quantity of 1 plus I. Ordinary general perpetuity payments at the end of each period with mismatched intervals, where P is equals to A over F using an equivalent rate. Lastly, general perpetuity due are payments at the start of each period with mismatched intervals, where we have P is equals to A over F times the quantity of 1 plus F. Now, perpetuities might sound like an abstract concept which is payments forever, but they're actually used in real financial planning like scholarship endowments and preferred stock dividends, and also certain retirement annuity structures. So the next time someone mentions an endowment fund that says pays out forever, you'll know exactly how to find out what that promise is worth today. So thanks for watching and drop any questions. Maybe we will see each other in the next video. Thanks for watching and bye.